In this video, I want to have a look at the log laws. So you guys are familiar now with index laws and how we can manipulate expressions with indices. We want to now have a look at how those translate to log laws. So they're both related. So one of the first index laws that we look at is if we've got a to the power of m times a to the power of n, it becomes a to the power of m plus n. So if they've got the same base and we're multiplying, then we add the powers. What that translates to as a log law is this. So if we've got log to the base a of xy, that's equivalent to log to the base a of x plus log to the base a of y. So just looking at those two things, you can see the relationship that this is times and this is plus. And over here, these are multiplied together and these are added together. So it's got that same relationship. Now in a minute, we're going to have a look at how to prove these so that you actually understand them. It's not just something that you have to remember. But first, let's keep going through the rest of them as well. So the next index law that you're familiar with is if we've got a to the power of m divided by a to the power of n, we're going to have a to the power of m minus n. So that's similar to this one up here, except instead of a multiplication, we've got a division, and instead of addition, we've got a subtraction. Now as a log law, that looks like this. So we've got log to the base a of x over y is equal to log to the base a of x minus log to the base a of y. So the bases are staying the same the whole way through. The last index law that we're going to look at is this one. So it says a to the power of m all to the power of n is equal to a to the power of mn. And equivalent to that as a log law is if we've got log to the base a of x to the power of n, that's equal to n times log to the base a of x. So like I said, at the moment, that's just a whole lot to remember. So we want to actually look at proving those so that you understand where they come from. So to prove our first log law, we're going to start off by letting x equal a to the power of m and letting y equal a to the power of n. So if we rewrite both of those as a log, in log notation, we'd have log to the base a of x is equal to m, and we would have log to the base a of y is equal to n. Now if we start off with our index law, if we had a to the power of m times a to the power of n, that would give us a to the power of m plus n. So that's the index law that we know. Now if we start replacing this, that a to the m times a to the n, well, a to the m is x and a to the n is y, so that is just x times y, or xy. And we'll leave that for the moment as a to the power of m plus n. So now this equation here is written in index form. If we rewrite that in log form, we're going to have log of base a of xy is equal to that power, which is our m plus n. But we know that m is log to the base a of x, and we know that n is log to the base a of y. So rewriting that, we'll have log to the base a of xy is equal to log to the base a of x plus log to the base a of y. So that's that first law proven. For our second log law, the process of proving it is fairly similar to what we just did. So we're still going to start with let x equal a to the m and y equal a to the n. We're going to rewrite those two equations in log notation just because it's going to come in handy later. So that means that log to the base a of x is equal to that power of m, and log to the base a of y is equal to the power of n. All right, so we're going to start off with index law that this is related to. So we had a to the m divided by a to the n is equal to a to the m minus n. Now we know that a to the m is x and a to the n is y. So this is x minus y, x divided by y equals a to the m minus n. If we just rewrite this to look like a fraction like it is up the top, we'll have x over y equals a to the m minus n. Now at the moment this equation's in index notation. Let's rewrite that in log notation. So we're going to have log, our base is a, our final answer is that x over y, and the power over here becomes our answer in this next one, which is m minus n. Now we can replace the m and the n. the m is log to the base a of x, and the n is log to the base a of y. So we've got log to the base a x over y is equal to log to the base a of x minus log to the base a of y. So that's our second one proven. To prove our third log law, we're going to start off by letting x equal a to the power of m. Now if we rewrite that into log notation, we would have log to the base a of x is equal to m. So that's going to help us a little bit later. Now if we have a look at x to the power of n, well, x is a to the m, so this is equal to a to the power of m all to the power of n. Now we know what the index law is for this, so that means that x to the power of n is equal to a to the power of m times n. If we rewrite this into log notation, so we'll have log to the base a of x to the power of n is equal to that m times n. But we know that m is log to the base a of x, so m times n is equal to, hang on, we'll write this side in back again as well. So m times n, I'm going to write the n first because when we're multiplying the order doesn't matter anyway. So we're going to have n times m, which is this. So we're going to have n log to the base a of x. So essentially with this one, if you've got a power, it can come out the front as a multiplier. There's a few other important things about logs that we need to be able to recognize. So we'll go through a few of them. So we've got log to the base a of a is equal to 1. And the reason that that's true is because a to the power of 1 is equal to a. Our next one is if we have log to the base a of 1, that's equal to 0. And that's because anything to the power of 0 is equal to 1. So these a's can represent numbers. It doesn't matter what numbers they are. All right, in this one here, we've got log to the base a of the square root of a is equal to a half. And that's because if we've got a to the power of a half, so we've got our base, our power, and that's equal to the square root of a. So it's just rewriting these index laws that we already know in log notation. Our next one, if we've got log to the base a of 1 over a, that's equal to minus 1. And that's because we know that a to the power of minus 1 is equal to 1 over a. And in a similar way with this one, if we've got log to the base a of 1 over x, that's the same as minus log a to the x. And that's because if we look at the third log law that we just did, if we look at this right-hand side of the equation, that minus log to the base a of x, we could bring that negative 1 that's out the front into the power. So it's log to the base a of x to the minus 1. And x to the minus 1 is 1 over x. So there are a few things that you need to be able to recognize as well when you're doing log problems. And the one last thing we need to know is that logs and indices are sort of mutually exclusive. They sort of cancel each other out. So if we have log to the base a of a to the power of x, that's just equal to x. Or if we had a to the power of log a to the x, that's just equal to x as well. So it's doing one thing and then undoing it both times. So you're just ending up with that x. So that's how to look at the log laws and how to prove them.